The third design pattern that we will look at is model view controller. That's a pattern that I hope that you've seen before because it's so useful in designing user interfaces that you'll see it everywhere. So in many contexts, Microsoft even has, I believe, a special version of this called model view model. And they also use MVC, model view controller. So if you take a look at the web page, the Wikipedia page, it's a lot of nice explanations. If you're not familiar with model view controller, definitely take a look at this. The idea is that there is a model of some data and there's a user. So this is one of those unique design patterns that involves the user. The user sees the view and uses a control like a button. The button will change something about the data or the model, and whenever the model is changed, it updates the view so the user sees maybe something different, clicks on some button or some kind of user interface object like button or JCombo box or whatever, and that changes the model maybe, which updates the view, users see something different, and so on. So a very standard way of interacting with users for users to interact with graphical user interface program. So it's used in web applications, in many languages, not just Java. It's JavaScript, MVC. It's used all over. So this was introduced way back in the 1970s. So if you can read this, but there was someone who introduced MVC into Smalltalk, the programming language that was in use, still is in use, but not so much, way back in the 70s. And so the MVC concept predates the idea of design patterns. So it's not actually it's actually not in the usual list of design patterns. The version of this is in design patterns, and it's called the Observer pattern. So it's related. It's very related. Observer is a little bit more general, but it's the same basic idea. Okay. So go back to model view controller. Hopefully you've seen some of this. Oops. And the basic idea is pretty simple. It's a design pattern that involves the user, and because it's usually applied to graphical user interfaces, you see buttons, those are the controllers, and then this affects some kind of model. It's a source of data. It could be a database, could be a differential equation that's being solved, whatever. And as you change something in the data, the view is changed. The user sees the view, maybe clicks on some other buttons, which changes the data again, and sort of goes round and round. Okay. There are many programs that have multiple editable views. For example, an HTML editor might have 3 different views. What you see is what you get view, which shows you the actual web page as it might appear. Then it might show you a structure view. It shows you just the structure where all the tags are, things like that. And then a complete source code view. Editing one view will update the other. So these are all sort of like behaving as views and also controllers. And so if you use an HTML editor, you're probably familiar with this. You can change things in the what you see is what you get view, which is the final way the web pages are presented in a browser, for example. And then you can change things in there so it acts like a controller. You can move around structures, that is the tags and stuff, and so not only do you see it, but you can also change it. So that's a special case, I guess, where the views are also controllers. And actually that's not that special. It's pretty common to have the views, like these 3 views, also serve as controllers. So the model, once again, is some data structure. It could be some database, could be actually just a way to get data from a remote database, and it has no inherent visual representation usually. The view is what visually represents the data that you get from the model. And controllers are what the user uses to interact and maybe change things. So controllers trigger some change in the data usually. So the views or controllers, usually controllers, update the model. The model tells the views that the data has changed, and the views redraw themselves. This is the usual sequence of events. So the user manipulates only the controller, and the controller in the code will update the model. The model, when it changes, will tell the view that the data has changed, and then things are redrawn. So here's a nice sequence diagram that shows this sequence of method calls. So the controller is what the user interacts with. We don't show what happens there, but let's say some JButton with an action perform method. We don't show the action performed, but assuming that the controller has been clicked, and then you tell the controller would say something like insert text into the model will send out a message saying something has changed, some text, in this case some text was inserted, and so it'll notify the view. The view will say, okay, something has changed, so I need to repaint. And so the way to do that would be maybe to get this new text, returns, and then does a repaint, and then it's done. It's been updated. Okay, so model view controller is used extensively in Java and other graphical user interface programs. The model, once again, is an object that models something, equation, phenomenon, transaction, database entries, things like that. View is an object that displays a graphical user interface window, like a JFrame. You might have some panel inside a JFrame window. And the controller is an event listener object, such as a JButton, things like that. So this is sort of built into Swing. Let me see if I can get this web page. There's a bunch of web pages in Oracle that tell you more about the Swing architecture. So this is like a pretty old article by Amy Fowler, one of the main people who designed Swing. And you can see one of the sections of this is the roots in MVC. So if you scroll down, you'll see that Swing architecture is rooted in the model view controller design that dates back to Smalltalk. So they were just showing, I was mentioning the same data that I talked about a little bit earlier. So you definitely, if you're not familiar with model view controller, read through this. It gives you examples of components that and the kinds of model interfaces they have. It tells you about graphical user interface states versus application data models. A lot of nice details in here. So it's a huge article that we're just not going to be able to go over right now. Okay. So a slightly different notation is also used in Java. The model is also called observable. For example, a class that has an appointment information for the entire year. The view is also called observer, which is actually the name of the next pattern that we'll look at. For example, a graphical user interface that displays appointments for any day of the year. And the controller is also called a listener in a lot of Java Swing packages. So for an example of a listener would be a class that responds to a user choosing a day. So the user clicks on a day, that would be a listener. So how do things work usually? In a Java graphical user interface, you might have something like this, a dialog box that says enter date. So this would be a controller. You click on OK, and that triggers an action perform method being called. You guys are all familiar with action performed, I hope. That action perform method, let's say it changes something, it gets some text from this text box, which would also be part of the controller. And so once it gets the text, it'll notify this model object, which is, let's say, a calendar. And the calendar might have a get appointments or set appointments. And the model, as soon as the date is set, will notify the view graphical interface that it should update. So the model might call the update method a view, And what view will do is get the list of appointments from the calendar, draw a list in the window, and then put in this new appointment. So the model or observable should not know the details of how views or observers are implemented. That's the main thing about model view controllers. Everything is decoupled. You could make everything into one object, the model, the view, and the controller. Make that into one object. Everything knows about each other, but that's just not a good design. The best way to design these things in general would be to decouple the model from the view and the controller. So once again, a model or observable should not know about the details of how views or observers are implemented, only that when something changes, all of the registered views should be notified. So you have to register views with the model. And so the model say update, and all the views should be updated. Each view or observer then asks the model for the current state and updates the display. So Java provides the observable class. So this is part of the Java API. And what you'll see is Java API for this class observable. So this terminology is also used in Java. It allows you to add observers, delete observers, set change method, and notify observers. So this is a way to organize your data into an observable. So remember, observable is the model. So you can use a subclass. You can create a subclass of observable to store all your model information. This has all these methods. And also Java has an observer interface so that you can interact with any subclass that implements observer. So if you want to create an actual observer, use subclass this interface. It has just one method, which is update. Why? Because the main reason for having observer is to have views. Okay, so each view has one method, and then all that method does is update the display. Okay, so the observer interface has the method update, which implements the response to a change. And so we'll talk about this observer pattern next. But I just want you to keep in mind that this observer interface is just another way of implementing model view controller. It's just happens to be available in Java, and also there is in the original list of design patterns, there was no model view controller, just observer.